This video should give you all the answers and explanations for how to solve the problems on motion diagram worksheet 1. So what we see here, just looking at this motion diagram, we see something that's moving at a constant velocity and it's moving towards the positive side. Okay, but remember, one of the first things that you want to do if you have a motion diagram, just look at where it starts, where it stops. So I know it starts on the negative side and it ends on the positive side. So it's got to get there somehow. And I know that because these dots are evenly spaced, it's a constant velocity. What that means is that my position needs to be a constant slope. So it's just going to go like that. All right, like I said, it's a constant positive velocity, so we see that. And that matches, remember, the slope here gives you the value here. And then the slope here of 0 gives you the value in this plot. So if we answer the questions, the object's acceleration is 0. The velocity of the object is positive the whole time. And the change in displacement, well, it goes in the positive direction, so that's going to be positive as well. Down on the bottom, this one gets a little trickier because it's two parts in one. It starts at the origin, goes towards the negative, and then comes back. So we know it has to start at the origin, it ends at the origin, and at some point it's down in the negative. Okay, well, look right here. Your initial velocity is a negative velocity. So that means your initial slope has to be negative. Okay, down here it stops because it turns around, so I know that I have to have 0 velocity there, meaning 0 slope here. And at the end, I have a positive velocity or a positive slope on the position graph. So I can see I've already started to draw this. I'm just going to continue it, and it'll look like a parabola right there. And like I just went over, we see the velocity goes from negative, ends at positive. And we can see the velocity is changing the whole time. So I need to make it so my value is changing the whole time. It looks like that, which is the same as the slopes, going from a negative value to 0 to positive. We see that here. This slope is positive the whole time, so my acceleration is positive. The acceleration of the object when it stops. Well, it stops right here halfway through. If I look, my acceleration is still positive. It's positive the entire time. The velocity of the object when it's farthest from the origin. So when it's farthest from the origin, which is right here, it has 0 slope, so it has 0 velocity. And my change in displacement over the entire trip, it started and ended at the origin, so that's going to be 0 as well. In number 3, I have something that starts at the origin and ends on the negative side. So I'm going to start at the origin, end on the negative side. I see that I have a negative velocity, so that means I have a negative slope to start with. And at the end, I'm stopped, so I have 0 slope. So I need to come down and curve that way. My velocity is going to go from negative to 0 because my slope went from negative to 0 from the position graph. So it'll just look like that. So my acceleration is positive and constant because that slope is positive and constant. The acceleration of the object, positive. The change in velocity of the object, okay, the velocity was negative the whole time, but it changed. The change became more positive as it went, and the change in displacement went from 0, it became more negative, so it's going to be negative. Down here, there are 2 parts. It tells you it's going to speed up, and then it's going to travel at a maximum constant velocity. So I'm going to break this down, and I'm just going to divide this up into the 2 parts. So the first part I'm going to do as it speeds up, second part as a constant velocity. You don't need these here, but that should just help you see what's happening. I'm going to start at the origin and go towards the positive. So from here to here, I need to go from 0 to positive. We can see that at the beginning, I start at rest. So my initial slope has to be 0 of the position graph because my velocity was 0. This slope is going to be positive because it's moving that way. So I'm going to start and curve up. Okay. So what that's going to look like, I go from 0 to positive. So I go from 0 to positive here as well, but this one's going to be diagonal. And that is a positive constant acceleration. Now the other part, once it reaches there, it goes at a constant velocity. That's just going to continue off at a diagonal value because a constant velocity means a constant position time slope. So constant velocity is going to just level out right there because constant slope, constant value. And if it's a constant value, that's going to be 0 acceleration. Acceleration of the object while it's speeding up, it's positive. The velocity of the object, even if it was changing at all times, we can see the velocity is always above the x-axis, so that's positive. The change in displacement at all points as well was positive. All right, number 5, if we look at this, we can see there is a constant positive slope, so that's a constant positive value. Constant zero slope, so constant zero value. So what we have is something that starts at the origin and continues to go at a constant rate over to the side. Here we have a negative slope and then 0, so I need to go from negative to 0, so I'm going to go up this way. That slope is positive, this acceleration is positive. Again, I'm starting at the origin, but this time I'm going towards the negative, and we can see that I have an initial velocity and then I'm slowing down, so it's going to be big and then getting closer together like that. This one, constant zero slope, so constant zero. That is a constant zero slope as well, so constant zero. If I do this, my origin is here. My object is staying in the same spot. That's my motion diagram, just one single object. Number 8 right here, we see this has a constant negative slope, so it's going to have a constant negative value. Constant zero slope, so that's 0. I started on the positive side over here, and I moved over towards the negative. I went past the 0 all the way to the negative over there. If I look at this one, I have a negative slope and then 0. So I'm going to go from negative to 0. I'm going to go up this way. That is a constant positive slope, so this is a constant positive value. I started on the positive side of the origin, right here. My last dot has to be at the origin, and I'm slowing down, so I'm going to look like this. Stops at the origin because this went to the origin. Here, this is a constant positive slope, so constant positive value for the velocity. Constant zero slope, so constant zero value for acceleration. In this one, I started on the negative side, so I'm right here, and I continued at a constant rate until I got right to that 0 mark. Last one, depending how you look at this, it'll look like one of two ways. You can either say this has 0 slope to negative and would look like this, or you can say it has an initial negative slope because it actually starts downward a little and becomes more negative, which would look like that. So I'd take either one of these answers depending on whether you said it started with initial value or initial velocity of 0 or an initial negative velocity, because this slope is either 0 or negative depending how you look at it. I'll take it either way. And this slope, either line though, is a negative constant slope, so negative constant velocity. When you draw this, I'm going to start on the positive side. Okay, either way, it's going to be a similar motion diagram. It's going to be like this, and it's going to speed up over to that side. So those are all the answers to this worksheet. Make sure you look all these over, and if you have any questions, come ask me in person.